Vibration analysis. Data collection. Displacement transducers. The two basic types are non-contacting and contacting. Both types require firm mounting. A bolted installation is required for permanent installation. However, a heavy-duty magnetic base and a Starrett flex oppost are satisfactory for most portable measurements. The frequency response varies by type and manufacturer, therefore, you must review the manufacturer's specifications to obtain frequency response, transducer sensitivity, etc. Generally speaking, the displacement transducers should be used to measure most low frequencies, below 10 Hz, and all relative motion measurements. Non-contacting displacement transducers require a power supply, a modulator, or a demodulator, normally called a driver, and a voltmeter. The transducer has a small wound wire coil at the end. When the tip of the transducer is placed near the target, about 0.040, the relative motion between the components supporting the transducer and the target can be measured. The driver generates a high frequency. When the frequency passes through the coil, a magnetic field is generated. The motion between the mount and target intersects the magnetic field. This movement is measured when the driver demodulates the signal. If the target is moving slowly, the depth of the finish or other metal disfigurations can be measured. However, at turbine speeds those items are not measured because the frequency response at such high frequencies is not very good. This means the relative motion between a turbine housing and shaft across the coupling can be measured, even when the shaft has teeth marks left from turning the shaft with a pipe wrench. The total runout or the amount of bend in the shaft can also be measured. If a keyway is under the transducer, a pulse will be generated. The data on the shaft can still be used if enough attenuation is used to prevent saturation by the pulse during data acquisition. After the data is collected, enough attenuation must be removed in order to measure the shaft runout. Saturation of the pulse does not affect the data after the data is collected. This measurement may not be as accurate, because of the amplitude scale, as when a keyway is not present. However, the data is still useful. Please note these measurements must be made in the time domain, and shaft speed should be about 6,000 rpm or below. The non-contacting displacement transducer has been used for years in high-speed turbo machinery. These permanently installed transducers with the associated vibration instruments are used for online condition monitoring. These systems may alert by turning on a light or ringing a bell. If the vibration becomes serious enough, the instrumentation may shut the machine down. When the proximity transducer is used in high speed, all specifications concerning shaft runout, etc., are much more critical. For example, 0.5 mils on a machine that operates at 5,000 rpm is about 0.13 inch per second or IPS, however, 0.5 mils at 10,000 rpm is about 0.23 IPS, and 0.5 mils at 20,000 rpm is about 0.5 IPS. The specifications for transducer installation in turbo machinery are found in the API specification 670. In slow-speed applications, 0.5 mils is of little consequence. This contacting displacement transducer must make contact with the target. The contacting portion is a machined rounded surface. The tip can be removed and has the same thread size as the tips on a dial indicator. This permits replacement of the tip with a variety of shoes or rollers. This transducer uses the linear variable differential transformer or LVDT principle. This transducer came out of the gauging industry, however, it is very effective in measuring low frequencies from DC to about 200 Hz. The measurement range and sensitivity varies. However, if the range is more or less than 200 mils, the normal sensitivity is 25 mV per mil. Note, the user should always refer to the manufacturer's specifications for the equipment being used. Dial indicators have been used for many years and will continue to be used for a long time. The usefulness of this tool is widely recognized. The development of the contacting and non-contacting displacement transducers establishes the dawning of a new era. The new era is the electronic dial indicator. If engineers, mechanics, millwrights, and technicians would start using the electronic dial indicator while the machine is in operation, to the same extent dial indicators are used on non-operating machines, untold millions of dollars could be saved in lost production and wasted man-hours and materials. Thank you.